Assalamualaikum warahmatullahi wabarakatuh. Hi everyone and have a good day. Before I start, let me introduce myself. My name is Nur Afifah binti Ismail, student from 4 BEA 1/1, Faculty of Electrical and Electronic Engineering Technology at Universiti Teknikal Malaysia Melaka U10. And my supervisor name is TS Aminurrashid bin Noordin. Today, I would like to present my project presentation to my panel, TS Dr. Sahazati binti Mat Rosali and Madam Rosilawati binti Muhammad Noor. Today, I would like to present my Bachelor Degree Project 2 with the title Trajectory Tracking of Wheel Mobile Robots.
Okay, next, Bachelor Degree Project 2, PSM2, Trajectory Tracking of Wheel Mobile Robots. Okay, next, this is my poster, Trajectory Tracking of Wheel Mobile Robot, which consists of introduction, problem statement, objective, methodology, result and analysis, conclusion, and project potential. Next is my introduction. Modern robots nowadays show how the development growth with the technology when a large number of researchers are handling with researchers on tracking control of wheel mobile robot years ago. Thanks to its limited work area, mobile robot have a wide area of application. Trajectory tracking is intended to allow the robot to follow a reference trajectory. The wheel mobile robot WMR is one such robot that has gained broad popularity due to its ease of control and usability. The wheel mobile robot comprises of two independently driven wheels. Next is problem statement. An important issue in mobile robot is the requirement to tackle external irregularities and confusion about the fact of dynamic principles that are in the environment. Mobile robot has been subject to external disturbance and noise in practical applications. The controllers suggested should therefore conceive to handle steady approximation error and outside disruptions. Objective A. To develop a MATLAB simulating model for a two-wheel mobile robot WMR. B. To design and simulate the controller for a two-wheel mobile robot. And last one, C. To compare the controller performance of two-wheel mobile robot. For the methodology, develop of mathematical model. This model is characterized in the global reference framework and describe the mobile robot velocity, but not the force or torque influencing the velocity. The design of the kinematic controller is based on the robot kinematic model. Assume that a zero vector is the disturbance term. This is the kinematic model of the robot. For the MATLAB and Simulink, this is the final design in Simulink. For the parameter gain, from the PID controller design in this Simulink, there are three gain parameters which are proportional gain Kp, integral gain Ki, and derivative gain Kd. For the membership function and rule base, in this part, the Mamdani fuzzy model is used as its type. This is the fuzzy logic is developed with its membership function and rule base. It has two input, E and DE, while has one output which is U. The centroid of area is used as its defuzzification strategy. The membership function for both input and end output, which are shaped like triangle and trapezoid with three fuzzy partition referred as 0, Z, positive P, and negative N. The range applied is between -1 until 1. Okay, next for result and analysis. There are two tables for the ISE Performance comparison between BID and fuzzy logic. For this section, analysis for this project will be explained about comparison of BID and fuzzy logic controller for trajectory tracking of wheel mobile robot. It will be divided to two movements of trajectory tracking, which are linear and circle movement. And then the performance index used is integral square error ISE. Will show the error display after the simulation start running. We can see here, this is the ISE table for BID and fuzzy. The first table is for linear movement and the second table is for circle movement, which is based on X for the linear, X is 1 and Y is 0. For the circle, X is 1, Y is 1. This is BID for linear and circle result of trajectory. And this is fuzzy logic, linear and circle result of the trajectory. We can see here from the ISE table, fuzzy logic controller is showing display the error value is near to 0 and more accurate, which is meant by no 0 is the best result. Okay, now we are here for the conclusion. In conclusion, all the objectives have been achieved in this project. After developing the trajectory control of wheel mobile robot efficiently, the mathematical model and the controllers play an important role. Furthermore, in realizing the objective of trajectory tracking wheel mobile robot, the selection of the model used also give an impact to the behavior of wheel mobile robot. Lastly, for the comparison between PID and fuzzy logic controller, the method and its function are considered to make sure the simulation can be run smoothly without any problem, and resulting choose fuzzy logic as the best controller for this project. Okay, for the project potential, trajectory tracking of wheel mobile robot offered to be a review of motion control problem and propose several control strategies in an environment free of obstacle. This project analyzed and compared two controllers, PID and fuzzy logic, that are most used as control strategies. This is because of their ease, simplicity of control, and versatility. Okay, for the last one, this is my detail at the bottom of my poster, which is consists of my emails and my supervisor email. That's all from my poster presentation. Thank you. Next is I'm going to show you my simulation result, which is in MATLAB Simulink. Okay, this is for my simulation result, which is I use in MATLAB Simulink. For the first one, so this one is kinematic model mobile robot or PID controller. This is the final design in Simulink. This is my kinematic control. Which is U and omega, and this is my ISE display for X and Y. This is to show desired graph, desired output, and this is the output. This is the graph. So firstly, for the initial condition, this is X1 and Y is 0. So here I change to 0 because for the linear, 1 x is 1 and y is 0. So I run this. It will show xy graph. This is the desired. Xy graph 1 is desired, which is linear. X start from 1 and y is 0, and this is the output graph. So the ISE here we can see, which is 0.7917, and y is 0 because it is linear. So only x that put difference into it. So here I will show you the script. So the result of the graph, this is the sine cos graph. So next one, I will change this to for the circle movement. So y I will put a 1, and then I will run this. The graph show xy graph 1 is for my desired, and xy graph is for my output. As you can see here, it start from 1, x1, and y is 0. Start here, and then it has some error, and it will follow and make the circle movement. You can see the error is also less than 1, and the graph, this is the side, it's sine cos graph. So this is for my kinematic model of your mobile robot, which is I using PID controller, which is this is the toolbox PID. This is the gain KP. I use the same KP for both, which is 2, and OKI 0.01, and KD is 1. So next one, I will show you for my fuzzy controller. This is for the linear, for fuzzy here. This is the fuzzy toolbox mostly. And initial condition I use is x is 1 and y is 0. So first I run this. The value of A, which is I use here, is 1 for both kinematic model. This is a compile. This might take some time. So the SY graph 1 is for desired, and SY graph is for output. This is for the linear movement. Start from 1, x is 1 and y is 0. So desired, and the output. You can see here the error. This is because linear, so it was supposed to be 0. So this, I'll show you the scope. Scope is more to near to reference. So next I'm going to show for the circle. So this is section to 1, and I run this. For the one means by one is for circle as a reference. This S1 SY draft 1 is for my design in SY draft for my output. This is for circle. You can see it has because it's from initial 10, so it has take some error. There was error before it makes a real circle movement. So this you see that its error is below than 1. This is the graph. Science cos graph. It is different from PID because PID has some error. This is more to design. So that's all for my simulation result for PID controller and fuzzy controller. That's all for me. Thank you.